Hello everyone, welcome to our SAT Math Guide, where in this video we'll be learning how to solve linear equations. So let's start it. In order to solve these type of equations, we must first know that x representing a variable will be equal to a representing a constant or a number. And thus that is what we will be looking for. So let's start with the example, because the SAT is full of bunch of them. In our first example, we will have a parent statement that will state the following. 9 times x plus 4 plus 2 less 2x is equal to 18. Alright, now that we have that, first we will have to apply the distributive. 9 times x means 9x plus 9 times 4, 36. That is added to 2 and then subtracting 2x, giving us 18. Alright. We already knew that. The thing is that now we must search for the common terms. For common terms, we have the following. We have x's and then we have numbers. So what we do is to add or subtract as well as to multiply or divide depending on the case. So we have 9x less 2x giving us 7x, 36 plus 2 giving us 38 equal to 18. What is our next step? Well, we must search a way to get rid of the 7 and of the 38 so that the x can stay alone at the side of the equivalence. So first, we pass the 38 to the other side to subtract, since it is adding. That means that 7x is equal to 18 less 38, giving us a value of less 20. And so let's keep on this side of the page. What do we do to have the x alone in a side of the equivalence? Well, we pass the 7 to the other side to divide, getting us an x is equal to less 20 over 7. And that is the result. That is the solution to our first example. It was fine, right? If it wasn't, then here are some other examples for you to practice, where our parent statement is 4x less 12 is equal to 10 less 4x. And so you may wonder, we have variables on both sides of the equivalence, and that is going to be kind of difficult when actually searching for the value that x will stand on. But no worries, because it's going to be simple. It's going to be simple enough that we first must seek what side we want for the x's to be in. I will choose the left side. So as our left side is fully 4x's, what we do is to pass the less 12 to the other side to add. It adds since before it was subtracting. 4x will be equal to 10 less 4x plus 12. Now that we have that, 4x is equal to 10 plus 12, 22 less 4x. And so now we must get rid of this x's and pass it on to the side of the equivalence that we have set for only x's. Since it is subtracting, it passes to the other side to add. And so it is. 4x plus 4x is equal to 22. 4x plus 4x, well, that's 8x. And so it will be equal to 22. Now let's leave this x alone. We have to pass the 8 to the other side to divide, since it is multiplying, leaving us x is equal to 22 over 8. But you may wonder, alright, so 22 is multiple of 8, right? And if it is, then what number must 8 multiply in order to reach 22? 3, right? And so 8 times 3 is equal to 20. The number we're searching for is 3. That will be our solution for our second example. And now, for a third one, we will now start looking at fractions. What do I mean by that? 1 over 3 of x plus 8, let's say it is equal to 3, alright? And so we must search for what x is equal to. Good. In this case, we must get rid of the 8, and so we pass it to the other side to subtract, leaving us with 1 over 3 times x is equal to 3 less 8. We already know that is less 5, right? Then what do we do? Since this 3 over here is dividing, we pass it to the other side to multiply. X will then be equal to less 5 times 3. And so less 5 times 3 gives us a value of less 15. That will be for the third case. And now for the last one, the fourth, will be more about fractions. Of course it is. We have 2 over 5 of x plus 1 over 6 is equal to 1 over 7. And so we must answer what is x. Alright, the first thing we must do is to find a common denominator between 5 and 6. So let's start with 5, 10, 15, 20, 25. We must search for all of the multiples between both until reaching a similarity. And so 4, 6 will be 6, 12, 18, 24, and then 30. So we can see that the common denominator is 30. Now what shall we do? Well, let's multiply all of our fractions by 30. 2 over 5x plus 1 over 6 by 30. And the same applies to the other side of the equivalence. 1 over 7 times 30. Alright, we must distribute it a little bit better. 30 will be at the end of each fraction, but remember the positive sign between those, alright? That can't be eliminated. Which will be equal to 1 over 7 times 30, giving us 30 over 7. Now, 2 times 30 is 60 over 5 of x, plus 1 times 30 is 30 over 6, equal to 30 over 7. We must try to find a way to simplify out those fractions. If we know that 5 times 10 is 50, then 5 times 12 is 60, right? And so 12x plus 6 times what number is 30? Well, 5. And that is equal to 30 over 7. That fraction cannot be simplified out due to there being no multiples. This 7 of the denominator must pass to the other side to multiply since it's dividing. It will remain 7 times 12x plus 5 is equal to 30. If 7 times 12x is 84x, then it will add 7 times 5, which is 35, and that equals 30. Now, let's pass the 35 to the other side to subtract since it's adding. 84x is equal to 30 less 35, meaning that 84x is equal to less 5. 84 will then pass to the other side to divide since it's multiplying. And so the answer for this fourth and last case is less 5 over 84. That will be the result for our fourth and last case for linear equations. With that being said, thanks for watching everyone. If you have any question, any inquiry, down in the comments you can ask me. And I'll see you next time.